postdoctoral researcher at the Aarhus University. The topic of my presentation is a conceptual framework for construction safety training using dynamic virtual reality games and digital twins. For past several years, construction industry remains as one of the most dangerous workplaces in the world. Despite having several structured traditional training methods, the injury rates are increasing. So there is a compelling need to improve the safety training in construction industry. So recent study shows that computer-aided training methods show several promising aspects in this arena, especially virtual reality-based training methods. These methods offer immersive and interactive experience for the users. So this developed interest in the participants and enhanced their safety performance. In addition to that, there is an option for collaborative training through multiplayer virtual reality games. And recent study shows that we can collect runtime data and assess the performance automatically by the end of the game. And based on this, we can give personal feedback to these participants, which will eventually help them to improve their performance. Even though VR training has several promising and effective aspects of it, but one of the major criticism is that they lack very complex tasks what we appears in the actual construction scenario. So the main objective here is to create tasks relevant to the training scenarios for the work we are actually experiencing in the real life. So the research objective is to propose a digital twin framework that dynamically generates and update a VR-based learning environment and uses that for construction safety training. This is an overview of the digital twin for construction safety. We have 4 major components: prevention through design and planning, right-time analysis and mitigation, conformance checking, and dynamic VR training. Dynamic VR training is the focus of the current study. This figure illustrates the conceptual framework for dynamic virtual reality training. So the aim is to train the construction worker in realistic environment with relevant tasks they are about to pursue in everyday life. The major works are highlighted here. It starts with the creating training scenarios based on the project intent information and project status knowledge we receive from the digital twin. Then selecting appropriate training scenario based on the upcoming work, and updating the VR games based on the progress of the work and also from the feedback of the decision makers and the performance of the laborers. Then once we update the game and present back to the laborers, we'll subject them to the virtual reality safety training. And during this training, we will collect automated data related to safety violations. This data will be analyzed and used for assessing their performance, and we can give feedback to them based on their performance in which area to improve. Again, based on the performance and how the work progresses, the VR game will be further modified and updated. During the entire life cycle of the project, every day before going into the work, the workers will be subjected to VR training and they will be better prepared for their work. Let me go into the detail, starting with the creating and selecting initial training scenario. Initially, before the commencement of the work, it starts with, we don't have a work already completed. So we have the as designed models and as planned processes. So creating a training environment, we require geometrical information, training tasks, hazardous zones, and objects of interaction. And initially, we use the as planned details, and later on, we use as performant built products and what has been performed so far. Based on the progress, we will decide the upcoming task. When it comes to the hazardous zone, we use the expert knowledge, that's a historical knowledge from the previous project. Based on the safety regulation, we identify in each training scenario what are the hazardous zone, and we will have a library of colliders, objects, and programs and data which will help us to create intractable objects to rectify the accidents or potential accident zones in the training scenarios. For example, you can see here the initial geometry of the particular training scenario is based on what we have in the plan from the initial BIM. Then in the particular case, we can see that a part of the work is already completed. Now the next work is the plant work is the plastering work. We can see some workers here. And we can also identify that there are some accident situation associated with it. For example, the open leading edge here. How do we fix that? The laborers will be provided with some objects they can interact with. For example, a guardrail or a barricade, so that they can pick it up, interact with it, and fix the unsafe condition which is occurred in the scene. AI-based safety training and automated data collection. During the training, each training scenario will have colliders to capture close call events or accidents. These colliders are programmed to identify the proximity of the participant with a particular dangerous situation or any kind of close call events. So these kind of data will be collected per participant to analyze what kind of accidents a particular worker put themselves into. So each person will be distracted in many ways. So based on that, we will have a personalized feedback given to them. And also, most of the time we have this, we can identify potential accident cases in the upcoming work as well. For example, you can see here, the leading edge will provide a data collection collider. So if any of the worker comes in proximity to this collider, the data will be recorded during that, what time, how many times the worker passes through this particular leading edge. So we will identify the close call event, potential falling hazards associated with that. Performance assessment. Based on the data collected, we will have runtime data analysis based on the background program with the gaming environment, and the assessed performance will be given to the decision makers to decide in which task needed improvement and how many times they have to subject it to further training based on that. And we are potentially expecting the laborers who are subjected to this kind of environment will have better situational awareness. These are some of the examples of the performance assessment. Updating training scenarios as the work progresses, and once the initial set of training is completed, the existing VR training environment will be updated based on the workers' performance and decision makers' feedback. For example, if there are any undetected hazards like that, such as cluttered objects, it may not seem like a hazard, but it might interfere with the work post-tripping or falling kind of thing. So these kind of undetected hazards in the previous scenarios will be incorporated in the further training. And if any of the safety solutions seems unfamiliar to the workers, they will be given additional training. And if you see that any of the existing solutions in the training environment, what we provide is inadequate, we will further improve the solution and training scenarios as well. As the work progresses, the training environment will be overlaid with the as-built 3D models from the digital twin, and the task will be updated based on the planned processes and completed work. These are some of the examples for the training scenarios. So the laborers will be, the participants will see examples like this in an unsafe scenario. They will be given objects to fix it to a safe situation, something like that. Conclusion. The current study, we propose a new concept for integrating virtual reality training with the information streams from the digital twin. This includes project intent information, project status knowledge, safety regulations, and historical knowledge. So the workers can be trained in realistic training environment with tasks relevant to their assigned work. And this will, since the worker will be subjected to the similar work environment they are about to go, their performance will be potentially improved. In addition to that, This dynamic VR training will be mutually beneficial to the digital twin for construction safety. This periodic data stream from the digital twin improves the training scenarios, while the training scenarios prior to the work will help to identify the conflicts such as conflicts in site layout, resource allocation, etc. Challenges and future work. One of the major challenge here is the technology readiness level of the construction industry. Currently, it is inadequate to implement the ITS procedure, and in future we can see the improvement. And also to create realistic training and management, we need detailed high quality data as the work progresses. And also implementing this is computationally expensive and economically demanding. And since each construction project is unique, the beginning of the project, it is a cumbersome work to create a project-specific training scenarios and VR environment. The future work includes the validation of the proposed framework and automatic creation of semantically meaningful training scenarios. Thank you. If you have any questions, please ask.
Thank you, Aparna. Actually, it's